thank you for joining another Telops webinar. My name is Ben Sote. I am the Scientific Product Line Manager here at Telops, and I'm very excited to share with you today two new products, the Radia V60 and the Radia M100. This is our new Radia series here. This webinar is being recorded. Link to the download is going to be provided for you here in a few days in an email follow-up. If you have any questions throughout this presentation, please feel free to use the question box below or on the GoToWebinar utility application, and we'll make sure that we sort of reserve some time here at the end to address those questions. So before we kind of get into things here, just a few words about Telops and what we do. So Telops is a company that is concerned with designing and manufacturing high-end scientific infrared cameras. Main facility is located in Quebec City, Canada, where we employ between 90 and 100 people. But we also have some offices in the US, France, and Asia as well. We were recently acquired by the Exosens group in late 2023. Now we sort of exist as a company within a portfolio of companies pursuing, among other things, scientific imaging across the entire infrared spectrum, or the entire electromagnetic spectrum, excuse me. Here at Telops, we have a comprehensive product line of scientific infrared cameras here. Just kind of run through these real quick. Starting on the top left, we have FTIR-based hyperspectral imaging systems. These are high resolution capability systems that are really well suited for things like gas detection and identification, mineralogy, things where we need spectral discrimination to identify different materials. Right below that, we have our multispectral systems. These feature a fast rotating 8-position filter wheel, which we can populate with spectral filters or neutral density filters for multi-channel imaging. And we can do this imaging at up to 100 frames per second for all 8 of those channels simultaneously. We also have high dynamic range cameras, allow us to sort of efficiently measure highly thermally contrasted scenes. And then back up on the top right, we have our fast cameras, which are unique on the market for their high frame rate capabilities. This includes the fast M3K and the fast M2K UD. These are the fastest cameras available on the commercial market for their respective detector array sizes. Geared our sort of entry-level line to include the Radia products that we're going to go over today. The idea here is to provide high-end systems at a price point that can sort of drive technology adoption to places, to customers who have not necessarily deployed this type of tech before. And then finally, we also offer a line of camera modules, which are designed and optimized for third-party integration tasks. So, on to our main topic of discussion here today, the new Radia family. So as I briefly sort of mentioned, Radia family represents Telops' entry-level offering for infrared cameras. We have 2 models in this family, the Radia M100, which, like other systems in the Telops product line, features a cooled infrared detector, excuse me. And then we also have the Radia V60, which is Telops' first sort of foray into the world of uncooled microbolometer cameras. So, as entry-level systems, the Radia family is optimized, of course, for the scientific data quality that Telops is known for, but also for ease of use, right? Both cameras feature small pixel pitch detectors, which allows us to get really nice spatial resolution capabilities, collect really high-quality imagery, sharp images, no blur, things like that. Both the Radia V60 and M100 are delivered from the factory with a radiometric calibration, which allows the users to begin acquiring the scientific data, really as soon as we turn the camera on. We're not going to have to perform sort of cumbersome black body acquisitions to update our calibrations. We will offer sort of a comprehensive array of lenses for both of these systems. It's going to allow the user the flexibility to make measurements of different size targets, different target distances. And then finally, the Radia cameras are very, very small, low swap, small packaging. Really is going to allow for integration and deployment into, let's say, more complex, larger experimental apparatuses. So, with all of these sort of factors combined, we see a strong market for Radia across a variety of industries segments, including, industrial R&D, university laboratories, and even sort of thermography inspection professionals. So we'll get into some of these applications here in a few slides. So with that introduction out of the way, let's take a look at both of these cameras in a little more detail, and we'll start here with the Radia V60. So Radia V60, this is an uncooled camera based on a long-wave infrared microbolometer detector. Features a 640 by 480 pixel detector array, 12 micron pixel pitch, and it is sensitive across the sort of traditional 8 to 14 micron long-wave infrared band. We can operate up to 60 hertz with this camera. V60 is delivered from the factory with a fixed integration time multi-point calibration. So this is going to enable calibrated measurements across 3 different temperature ranges, which you can see below here. And it also is going to allow the data to be displayed in units of digital levels, radiometric temperature, in-band radiance, or in-band irradiance, just like Telops traditional calibration. Camera control and acquisition is going to be controlled by Telops RevealIR software. We have full integration into that software package. And data management is going to be handled through a GigE Ethernet connection. V60 is fully integrated into RevealIR, which is Telops scientific software that does camera control, data acquisition, and some sort of limited data processing tasks. As we sort of talked about in the last slide, that radiometric calibration delivered from the factory is a multi-point calibration, which means that the user is going to be restricted to certain camera operational parameters, most notably fixed exposure time and window size. So we can select the raw mode in RevealIR software, which enables sort of this advanced user mode, which we're just calling raw mode. It's not a very creative name, but it describes what it does here. And this raw mode allows the user to sort of freely change a variety of measurement parameters at the expense of providing these calibrated measurements. So, when we're operating in raw mode, the camera will disable thermography measurements, will disable the bad pixel replacement, and return only sort of the uncalibrated, uncorrected digital levels. This mode was really implemented to give maximum flexibility to a user who may want to modify some of these parameters for their, for their specific experiment, but might not need that calibrated information that were enabled by our radiometric calibration. So this is just a sort of advanced user mode here to provide a little bit more flexibility. So a few more details here about the radiometry, the calibration. So the calibration delivered with the V60 includes 3 sort of operational modes with different valid temperature ranges. We have this high sensitivity thermography mode, which is designed to provide a high sensitivity, low NETD performance over this limited 10 to 40 C temperature range. We've also got our standard thermography range, which is a little bit wider, covers the -20 to 120 C temperature range. And then we've also got this high temperature thermography range, which is valid from 50 to 400 C. Calibrations are performed for the entire optical path, which includes the camera, the lens, filters, any other sort of optical elements that are placed in that path. So currently with the V60, we're limited to calibrating a single optical path per camera. So that means we are limited to 1 lens per camera, but we are working very hard to eliminate this restriction. We anticipate being able to offer calibration of multiple optical paths per system in 2025, which will make it really a user swappable kind of lens system at the end here. Our calibration is really designed to give sort of maximum flexibility to the user. So, as a result, we've enabled the ability to switch between these different calibration modes at will, right? So we first have the calibrated mode, which allows us to assign a physical unit to the detector signal and view this collected image in units of temperature, radiance, or irradiance. The user also has access to the nuke imagery, the non-uniformity correction imagery, which allows the data to be viewed in units of digital levels with a gain and an offset correction applied. And then finally, we have the raw data always available. uncorrected raw data, viewable in units of digital levels, again, just like the nuke mode. So remember that when you select the raw mode in RevealIR software, this is going to enable our sort of advanced user mode, where the user has additional flexibility to the measurement parameters, that's prevented when we are using these calibrated data outputs. So on the commercial side, what are we offering here, right? The baseline product includes the camera, RevealIR software, and a radiometric calibration for the lens of your choice. Just as a reminder, within our radiometric calibration, we have the 3 operational modes with their sort of distinct temperature range coverage. I'll say here that we really aim to expand this calibration offering in the near future, particularly towards higher temperature targets. And of course, we'll make those calibration upgrades available for any existing users of the V60. On the lens side, you can see the 3 options that we're offering here. Our goal is to provide an array of choices that will allow you to effectively measure your target, whether that target's right in front of you or 100 meters away or what have you. We launched this product in October. We're anticipating the first deliveries to begin in Q1 of 2025. On that note, I will say that we are currently offering an introductory discount on this model for any orders that are placed before December 15th, 2024. So, if you have interest in capability and some year-end budget that might support an acquisition, please reach out. We can get into the details, tell you all about these discounts that we have available right now. Okay, I got a question here. Let me just make sure. Okay, we'll save these questions here for the end, but I have noted your question, and I'll make sure that we address that. Okay, so that was Radia V60. Again, it's our first sort of attempt to enter the world of uncooled scientific imaging, so it's an exciting new product for us. We're looking forward to getting into it and learning a lot more about that world. The next product here I would like to talk about is Radia M100, and this is more along the lines of what Telops has been doing with its scientific product line, in that it uses a cooled detector. Right. So this product is unique, though, not only for its size, which is, much more comparable to sort of a, maybe a high-end DSLR camera than sort of the loaf of bread or toaster oven form factor of some of our higher-end cooled cameras. But also it's unique because of some of the performance characteristics, and I'll get into that here shortly and tell you what's unique about this camera. All right, so this slide here shows the main specs of the Radia M100. We have a 640 by 512 XPN detector array, which has a 10 micron pixel pitch and is sensitive over this 3.6 to 4.2 micron midwave spectral band. So it's sort of a smaller spectral band than the traditional midwave 3 to 5 band, but this does allow us to offer this baseline calibration from 0 to 850C. So yeah, the radio comes with a factory calibration, just like the V60, but unlike this multi-point calibration with the V60, the cool detector of the Radia M100, it allows us to implement our sort of traditional Telops calibration scheme. So this is a unique calibration on the market with some really nice usability features. Most importantly, to my mind, is the ability to change any and all of those camera parameters on the fly without impacting the quality of the radiometric measurement. So that includes things like the frame rate, the exposure time, the window size. You can change all of those parameters at will. You never have to put a black body in front of the camera to sort of update the calibration table. So really nice from a usability, ease of use perspective. So yeah, like I said a little bit earlier, the baseline temp range on our calibration goes from 0 to 850 without the need for any neutral density filters. This can be extended out to 2500 C with the addition of a single attenuating filter. Excuse me here for a second. Also got a comprehensive lens offering for M100, which, like the V60, are optimized for short, medium, long range target imaging. Unlike the V60, however, the lens options for the M100 are fully user swappable. The M100 is also completely integrated into RevealIR for camera control, image capture. And for the first time, we've implemented a USB 3.0 data transfer link for easy connection to sort of consumer-grade laptops without having to put, camera link acquisition cards in there or anything like that. On the commercial side here, baseline product offer includes the Radia M100, Telops radiometric factory calibration, and RevealIR acquisition and control software. The lens offering, again, includes short, medium, long range options, just like for the M60, but again, with the M100 here, we are fully user swappable. So this means that the user is able to calibrate one or all or two of the compatible lenses and switch between them at will with a simple calibration file change. So again, this is a really great usability feature. You can sort of swap back and forth between experiments, as you need to. Radia M100 launched again back in October 2024 with the V60. Anticipating first deliveries for this product in Q2 of 2025. All right, so we talked a lot about specifications, calibrations, capabilities, but where can we use these cameras? What does the application space look like, right? So to my mind, the space is broad, and I'm I'm pretty excited to work together with our customers to discover, push the boundaries of where these cameras can be deployed. But for the next couple slides here, I've got a taste, I guess, of what we can accomplish with the Radia family. So one of the areas where we see really strong potential is in the industrial R&D space, specifically in the automotive R&D world. We all know that there's sort of myriad components and systems included in a car that generate heat. So small form factor scientific infrared imaging can provide diagnostics, performance information on a range of these subsystems: engines, braking systems, tires and wheel components, climate and HVAC systems, which I think is nicely illustrated here in these measurements that were taken by my colleague Antoine back a few weeks ago of his car's heated seating and sort of windshield defrost, I guess you call it. With the Radia V60. So these are really nice sort of first application measurements that we're able to get. Moving on in that industrial world, Radia family products represent a really strong technical capability for a variety of, let's call them monitoring and inspection tasks. So we've got high performance and low cost of the Radia family. We think we can deliver strong value for predictive maintenance tasks, things like identification of overheating or malfunctioning electrical components, buildup of heat and bearings, things like that. Process monitoring is another area where we're measuring and visualizing the thermal distributions generated through welding, injection molding, metal forging, and some of these other sort of heavy processes for quality control purposes. We think Radia can also provide a lot of value to the energy generation space, providing a capability for the inspection of turbines, boilers, furnaces, for performance degradation, or even monitoring the condition of safety critical components here. Infrared imaging technology, I think, is becoming sort of increasingly adopted by service and inspection professionals, as a tool to monitor, let's say, anomalous heat patterns, right? Building inspectors, for example, commonly use IR imaging to identify heat loss through windows, monitor insulation efficiency, detect moisture intrusion, just to name a few. There's, a wide variety of things you can do with an infrared camera when you're doing a home inspection, for example. We can also apply Radia to electrical inspections, identify overheating components, overloaded circuits, faulty connections, mechanical inspections, leak inspections, solar panel inspections. If there's something that needs to be inspected and it generates heat, infrared imaging can be a great tool. And I think the Radia family provides a unique combination of sort of scientific imaging performance, ease of use, and really value at the end of the day. So my final application slide here is meant to highlight some of those unique characteristics of the Radia M100 that I mentioned earlier, particularly towards some prominent research areas that we find in universities. So first, M100 is really well suited for measurements in the combustion, fire protection engineering, wildfire research areas, things like that. And that's because the M100 detector has a very high tolerance for saturation, and that's in part due to that restricted spectral band, that 3.6 to 4.2 spectral band that we're using here. So this characteristic, this performance characteristic, allows us to offer that baseline calibration from 0 to 850 without using a neutral density filter. It really improves the performance of M100 over scenes that have very strong thermal contrast. Coming from another direction, 10 micron pixel pitch of the M100 yields really, really good spatial resolution performance, which, when we couple it with high thermal sensitivity, it allows for good performance for materials testing experiments. So these measurements typically require the characterization of very complex thermal fields that can be induced by stresses applied to these different materials. These kinds of measurements allow us to do things like measure the thermal conductivity and heat transfer coefficients, characterize thin films, and to be able to perform these kind of advanced imaging techniques like digital image correlation, for example. So to sort of wrap it up here, we're very proud, very excited about the new Radian line, which includes our cool detector option in the M100 and our uncooled microbolometer system in the V60. Main benefits with this product line lies within scientific data quality and the radiometric calibration that really allow for high accuracy and high sensitivity thermal imaging measurements. Both of these systems exist in low swap, small form factor packaging, which is ideally kind of suited for deployment into tight spaces or sort of complex experimental environments. Full lens selection here, which allows the user the flexibility to sort of fill all of their measurement needs for targets that might be at different distances or different sizes. So, overall, I think the Radia series represents a really unique combination of high performance infrared imaging, low swap form factor, and sort of a value-oriented commercial offering. So I mentioned this before, but we are extending a product introduction discount for both Radia V60 and M100 until December 15th. So yeah, if you have interest in either of these products, please get in touch with us and we'll be happy to work with you on these products here. So that's it. That's all I've got here for today. Thank you very much for your time this morning. I know I did get one question here in the chat box. Let me see if I can pop this out. Does the V60 support sub-windowing and higher frame rates greater than 60 hertz? No, 60 hertz is the cap that we've got on the V60 here. So it's not a high-speed camera by any means. When we typically think of Telops cameras, the high-speed suffer. It's not a traditional Telops high-speed camera, but 60 hertz does get you a little bit of capability to measure moving targets, let's say. Let's see, one more question just came in. Difference in sensitivity to ambient temperature. Yes, that's a good point. That's a good sort of distinction between the cooled and uncooled technologies. The uncooled camera, as you can imagine from the name, the detector does not have any cooling on it, and as such, it is therefore sensitive to the ambient temperature in the room, in the environment in which it's being operated. So with the V60, for example, we recommend setting up the camera and letting it run for 30 minutes before taking any measurements. But with the M100, we've got the cool detector, so we've got thermal compensation for the ambient temperature built into that camera there. So that is, you don't have to worry about that with the M100. All right. Thank you very much, everyone. We will record these questions and provide the answers in a follow-up email here in a few days. And then again, please feel free to contact us if you have any questions, and we will see you next time. Thank you.